We're working on Chapter 9, Section 5, which is Learning Plan 5.4 in our book. We're going to graph quadratic functions. Remember, quadratic means it's going to be squared, and these are functions. So we're going to have f of x equals that. And then we're going to graph them if they have a horizontal shift or if they have a vertical shift. And then use the coefficient to predict whether they're going to be up, down, whether they're going to be wide or narrow. Find a quadratic function to model data, which is actually pretty easy in Excel. All right, so how do you graph a quadratic function? The first thing that you do is you have to notice, you've got x and you've got x squared. So if x is 0, 1, 2, -1, -3, if x is 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, -1 squared is 1, -3 squared is 9. So our points are 0, 1, over 2, up 4, back 1, up 1, back 3, up 9. So our function is a curve. Actually, this curve is called a parabola. The lowest point is called the vertex of the parabola. You know, what's interesting about parabolas is that they are symmetric across the line that goes through the vertex, so that this point is as far from the center line as this point is. Any function that can be written with the x squared term is a quadratic function. The only rule is that a can't be 0, because if a is 0, then it's not quadratic anymore. Okay. These graphs we said are called parabolas. We use the variable y and function notation interchangeably. Although we use the letter f most often to name quadratic functions, other letters can be used. We use the capital letter F to distinguish between different parabolas graphed on the same coordinate axes. Okay, so parabolas do not need to have their vertices at the origin. Let's look at this one. F of x equals x squared plus k, and graph that. So x squared plus k. If x is 0, if x is -2, -2 squared is 4, plus 3 is 7. -1 squared is 1, plus 3 is 4. 0 squared plus 3 is 3. 1 squared plus 3 is 4. 2 squared plus 3 is 7. So back 2, up 7, back 1, up 4, 0, 3, 1, 4, 2, 7. If you notice, all that happened is the parabola got shifted 2 up. Remember before when we drew the parabola, I'm going to change colors to remind you what the first one looked like. It looked like this. And get that second dot correct exactly over there. But anyway, you can see that this one is shifted 3 higher than the previous one. Give the vertex. Here's the vertex, 0, 3. The domain is all the real numbers. The range is from 3 to infinity. Bracket 3, comma, infinity. So you graph this one. Now really the vertex is down here at -3. So -2, so it's x squared minus 3. -2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. 0 squared minus 3 is -3. -2 and 1 again. So our graph actually looks like this. I just didn't get the graph paper down far enough. And you can see that when you have a number like that, it's going to get the axis down. So if we have a number connected to the x squared like that, it's going to be shifted vertically. So this is the vertical shift letter. And if it's greater than that, it's going to go up. If it's less than that, it's going to go down. And the vertex is at 0k. Now, what happens if we have the number connected with the x? If you notice before, the number wasn't connected to the x. Now it is connected to the x. So we're going to -5 plus 2 is -3 squared is 9. -4 plus 2 is positive, or -2 squared is 4. -2 plus 2 is 0. 0 squared is 0. 0 plus 2 squared is 4. 1 plus 2 squared is 9. So back 5, up 9, back 4, up 4, back 2, up 0, over 0, up 4, over 1, up 9. So you see how the parabola looks. Now what happened this time is, if you notice, if the number is connected to the x, it's going to shift the x. Now we would expect a positive number to shift it in a positive direction. Why does this shift it in a negative direction? And that's pretty easy to see, because when you let's see how to say this. What it's actually doing is it's moving the graph 2 spaces forward. So 0 was here, now it's 2 spaces forward. That's why it works out that way. It's the same as before. 0 was here, now 0 is 3 spaces down. Okay, next one. You do this one. Okay, -5 plus 4 is -4 squared is 16. -5 plus 1 is -4. Yeah, squared is 16. -4 plus 3 plus 1 is -3 squared is 9. -2 plus 1 is -1 squared is 1. 0 plus 1 is 1 squared is 1. 1 plus 1 is 2 squared is 4. Okay, so we've got -5, 16, which is up here, -4, 9, -2, 1, positive, or 0, 1, and 1, 4. As you can see, our graph comes down like this, and the vertex isn't even one of the points that we graphed this time. The vertex is actually right here at -1, 0. Okay, what happened this time is that the graph got shifted forward 1, which made the axis shifted forward 1, which made the graph go back 1. So, whenever they did it this way, they said, yeah, any number that's connected to x is going to move the x-axis. Okay? If x is positive, it's going to move it backwards. If x is negative, it's going to move it forward. Remember before, if the number wasn't connected with the x, it moved it up. If it was positive, it moved it down if it was negative. And the vertex is at h0. So whatever number that is, is going to move the graph. Now what happens if you do both of those, move both of those? Well, we can substitute in 0 minus 2 is 4, is 2, squared is 4, plus 1 is 5. 1 minus 2 is negative 1, squared is 1, plus 1 is 2. 2 minus 2 is 0, squared is 0, plus 1 is 1. 3 minus 2 is 1, squared is 1, plus 1 is 2. And 4 minus 2 is 2, squared is 4, plus 1 is 5. So over 0, up 5, over 1, up 2, over 2, up 1, over 3, up 2, over 4, up 5. So you see the graph looks like this, and that's because, I'm going to change colors, this shifts it up 1, and this shifts the axis back to, 1, 2, or shifts the graph forward 2. So on this one, you try, we forgot to give the domain. The domain is from infinity to infinity. Vertex is 2, 1. The axis of symmetry is x equals 2, and the range is from 1 to infinity. Okay, I'm gonna do this one by using the rules that we just learned. The 1 tells us to go back 1. The negative 2 tells us to go down 2. So that's where our vertex is negative 1, negative 2. The axis of symmetry will be x equals negative 1. And so I'm going to graph it even without filling in the values and then show you that those values are correct. So our graph looks like this. Okay, let's put in the values just to make sure. 0 plus 1 is 1. Squared is 1 minus 2 is negative 1. 1 plus 1 is 2. Squared is 4 minus 2 is 2. 2 plus 1 is 3. Squared is 9 minus 2 is 7. 3 squared is, or 3 plus 1 is 4. Squared is 16 minus 2 is 14. 4 plus 1 is 5. 5 squared is 25 minus 2 is 23. Obviously, our dots are getting pretty far up here. 2 is 7. I didn't quite hit that one. But you can see that we got this half of the graph, and then you can, by the axis of symmetry, draw the other side of the graph. Okay, so in a parabola, the vertex is this number and this number. The axis of symmetry is this number, and that's how we can graph them. What happens if we have a coefficient in front of the x? Okay, let's see what happens there. So in other words, now if x is negative 2, negative 2 squared is 4, times negative 2 is negative 8, minus 3 is negative 11. Negative 1 squared is 1, times negative 2 is negative 2, minus 3 is negative 5. 0 minus 3 is negative 3. 1 squared is 1, times negative 2 is negative 2, minus 3 is negative 5, and so on. Okay, so back 2, down 11, back 1, down 5, back 0, down 3, forward 1, down 5, forward 2, down 11. Okay, now an interesting thing happened here. This 3 still made the graph start down 3. But what did the negative sign here in front of the coefficient? Before, they've always been open up. This one is open down. And then the 2 here tells us, this 2 tells us that the points are twice as far apart as we would accept, or it's stretched out twice as far. So, excuse me, the vertex is at over 0, down 3. The axis is at x equals 0. The domain is from negative infinity to positive infinity. And the range is from negative infinity to negative 3. You do this one. Now, interestingly enough, since it doesn't have an x and y, we know that the vertex is here at 0, or not an x and y, an h and a k. We know that the vertex is here at 0. Okay? It's downward 3 times as far. So our graph is going to go like this. It's going to be 3 times as fast. Let's just make sure that that's true. Negative 2 squared is 4 times negative 3 is negative 12. Negative 1 squared is 1 times negative 3 is negative 3. 0, negative 3, negative 12. So, now we've got another thing to add in. This tells us, right? This tells us how far up and down to go. This tells us how far left and right to go. This tells us how stretchy it is. And if it's negative, it tells us it goes like this. If it's positive, it goes like that. So all of those different things help us graph these parabolas. Let's look at this one. Now I'm going to graph this one without using the table of values. This number that's all alone tells us how far up and down we go. We go up 1. This one tells us how far left and right we go forward 2. Now that's the one that's kind of tricky. You would expect it to be backward, but remember it's x minus h. Okay. And it's happening half as fast as usual. And notice it's positive. So usually we would go over 1, up 1. We're going to go over 1, up a half. Back 1, up a half. Over 2, we usually go up 4. We're going to only go up 2. And you can see how our graph looks. It's much fatter than usual because our graph is happening half as fast. Half as fast. You do this one. Okay, this 2 tells us that we go up 2. And oops, I'm getting the colors so that you can see how things are related. This 1 tells us that we go forward 1. When it's negative, we go forward. So that's where our vertex is. This 2 tells us, I'm going to change colors again. This 2 tells us that it's happening twice as fast. So usually we would go over 1, up 1. We're going to go over 1, up 2. So it's skinnier than usual. Okay, and that's how you do those problems. Practice will make perfect. What do you do if you know something is a quadratic and you're trying to figure out what you've got for a quadratic equation? Well, in this case, we know that if they're telling us that it's a quadratic, we've got three choices. Instead of using these three, I'm going to use this one. I always like to use 0. This one, 1. I'm going to use 2 just because I don't want to get something times 6. That just makes it unnecessarily difficult. So we've got a times 0 squared plus b times 0 plus c equals 4973, which tells us that c is 4973. Let's go to the second equation. A times 1 plus b times 1 plus 4973 equals 0. Let's go to the third equation. A times 2 squared, which is 4, plus b times 2 plus 4973 equals 0. Oops, I didn't get that right. This isn't 0, it's 5939, and this one is 6737. Okay, let's take those last two equations there and rewrite them. A plus b, and if you take 4973 away from 5939, $49.73, you get 966. And then 4a, I'm doing this equation now, plus 2b, and now subtract 49.73 from this, you get 4, 6, 7, 1. Okay, so you've got two equations here that you can, let's see, what's the easiest way to solve those? I'm going to try substitution. I'm going to rewrite the first equation as A equals 966 minus B, and substitute that into the second equation. 4 parentheses, 966 minus B plus 2B equals 1764. 4 times 966 is 4, carry the 2, 6, carry the 2, 3864 minus 4b plus 2b. So subtract 3864 from both sides, you get 0, 0. What is that? 1900 is negative 2b. So b is negative, no, I'm sorry, this is negative. b is 950. So we've got our equation so far. We know C is 4973 and B is 950. And so we need to know what A is. A is 966 minus B. 966 minus 950 is 16. So 16x squared. So here's our quadratic equation. Now, interestingly enough, I did this in Excel, and I got, that equation there. And notice I used the points 1, 6, and 10. I'll show you how I solved that part using Excel. And then, okay, so I'm going to use the points that are in the example on page 535 to solve the quadratic equation. So the 3 points that we're supposed to use are 0. Put it up here. 0 is 4973. 4 is 7321, and 10 is 6694. And when I use those 3 points, I'm going to make a scatter plot. And now with that scatter plot, I'm going to add a trend line, but it's not going to be linear. It's going to be polynomial, order 2, automatic. I'm going to display the equation on the chart. And when I do, you can see that I have, this is my formula, which if you notice matches the one in the textbook perfectly. I'm going to change my points here to do the ones that I graphed. What was that? 0, 4973. And then 1 was 5939, and 2 was 6737. And when I do those points, let's see here. 1, 4973, 4, 5939. 6737. And if you notice there, well, that doesn't seem like the same numbers I got. I must have had a wrong number because I think mine was 950 in the middle and negative 16 was out front. I don't know. My math must have been bad when I did that graph. Anyway, that's how you do that, and we'll see you next time. Bye now.